the GPAs of a sample of 26 community college applicants were selected and listed in ascending order below. We're advised not to use a calculator for this problem. The first thing I like is that they told me exactly how many data points there are. That's helpful, and I also know that they're in ascending order, so I don't have to worry about going through and checking that they're order or reordering them. Those are kind of difficult tasks. Because there's 36 data points, I know that the middle is going to contain two numbers, right? This is an even data set, so there'll be two numbers exactly in the middle. And in fact, half of 26 is 13, so it should be the 13th and 14th value that sit in the middle. So if I was to count, I could go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So these two, right, are the two values that I'll use to calculate the median. Remember, if there's two values that sit in the middle, because this line represents the middle, if there's two values straddling either side of the middle, we take their average to calculate the median. And then in order to find Q1 and Q3, we're looking at the middle of the lower half and the middle of the upper half. Now, because there were 26 values and I took away 2 of them, there's now 24 remaining. 12 of those are below the 2 that are in red, that I've boxed in red, and 12 are above. So if I was to count 6, 1, 2, 3, 4, 5, I lost track. Let me get a different color. 1, 2, 3, 4, 5, 6. The 6th and 7th values now here constitute Q1, right? There's 2 of them, so we're going to find their average, add them together, divide by 2. And then the middle of the upper half, I'll do in green, 1, 2, 3, 4, 5, 6. These 2 values represent Q3. So in order to find Q1, the median, and Q3, I'm going to just find the average of those numbers that I've boxed up. The other 2 numbers that are in our 5-number summary are the minimum value and the maximum value, and clearly those are pretty easy, right? Our minimum and our maximum are here. So let's go ahead and write down the 5-number summary. So our minimum is 1.58. The maximum is 4.29. And I am going to use my calculator to find the average of these numbers. So I've got 2.46, and I'm adding to that 2.5, and I get 4.96, and half of that is 2.48, so that's Q1, 2.48. Same thing for the median. I'm just taking 2.83 and I'm adding to that 2.99. Oops, not that. 2.99 and dividing that by 2, and I have 2.91. And then finally for Q3, I'm taking the 2 values in green, the middle of the upper half of the data, 3.49 plus 3.54, and taking half of that also, and I get 3.515. I'm going to record all that. So 3.515. So there's our 5-number summary. It tells us a lot about our data. It kind of gives us, well, we can see the range, right, the minimum to the max. We get kind of an idea of the spread of the data. Is it clustered closer to the median, or is it more spread out? And you can see that when you create the box plot too. This problem goes on, and it says on grid paper, create a combination histogram and box plot. So the first one we've done, right? We've created several histograms. I'm sorry, box plots, but we haven't created a histogram yet. So they're trying to, give me an idea of what a histogram might look like, and they're also giving me something called the interval. So this is the interval we're going to use for our histogram of a half. We're going to use an interval of 1/2 or 0.5, and we're going to create. It says the combination histogram and box plot starts with the histogram. Then place a box plot on top of the histogram. Help with creating a box plot is in the math notes, and I think we've looked at those in class even. Use the same X scale for both the histogram and the box plot. So our smallest value in our data set is 1.58. So I'm thinking, since we're going to count by 5, it might be nice to just start our histogram at 1.5, and then we would go to 2, and then 2.5 and 3, etc. for the scale for the histogram. Let me pause the video and I'll set that up and talk about it with you. So this is my initial setup for my histogram, and you can see my minimum value is 1.58. So I've decided to start my histogram at 1.5, and at the textbook suggestion, I'm using an interval of size 1/2. So I'm going from 1.5 to 2, 2.53. Now what we do is I need to count my data values, and if a point is, and you can think about this in terms of if it includes the 1.5 and goes all the way up to but doesn't quite include 2, it gets placed into this bin. So this is a bin, and let's say for example there's 3 values in our data set that fit this. I would create this showing that there were and I need to scale this axis, 1, 2, 3 values that were in this range. But if I was given the value 2, I wouldn't include 2 in this spot. 2 would go in the next one over. So when I say it starts at 1.5, this one starts at 1.5, it goes all the way up to 2, but it does not include the 2. So that's why I'm using this open circle here, like we've been graphing inequality. So the 2 is not included in this bin. It would go in the next one up. So let's look at our data and figure out what we've actually got going on up here. So in our actual data, we only have 1 value in that. No, we have 2 values in the first bin, right? So let me erase all this now because we know what's going on. Let's see if we can just circle our bin. So the first one was 1.5 up to but not including 2. So there's 2 values in that bin. The next one started at 2 and goes up to 2.5, so it would include all of these values, but it doesn't include the 2.5. So I've got 1, 2, 3, 4 values go in the next bin. So let's go down and look at what that looks like on the histogram so far. So far what we would do is the first bin has 2 values that fell in it. So we would draw this. The next one had 4 values in it. So what I would do is I just jump up here and go over and then right down to here. So this is how we complete our histogram. I'm just going to count up the number of values in each. Remember, this bin starts at 2.5. It goes all the way up to 3, but it doesn't include the 3. This one starts at 3, goes all the way up to 3.5, but doesn't include the 3.5. So what we're looking at here is where it begins, and we're looking at the up to but not including value at the top of the bin. So I found the values for my remaining bins. I believe the next bin over will have 8 values. It starts at 2.5, goes all the way up to but does not include 3. So that's the values 1, 2, 3, 4, 5, 6, 7. There's 8 of those. The next one starts at 3 and goes all the way up to but doesn't include 2.5. So that would include 1, 2, 3, 4, 5, 6 values. The next one starts at 3.5 and goes all the way up to 4 but doesn't include the 4. 1, 2, 3, 4, 5. And the last one includes the 4.29. Most of the time, it's not an issue of thinking about is this value included in this bin or not. It's just if you get a value, for example, if I had a value that was exactly 4.0, that value would be included in the last bin. It wouldn't be included in this one. But I don't think there's any problem. I don't think I had to decide whether or not that was the case here at all. So I've got a 2, 4, 8, 6, 5, 1. So we could quickly complete this. All right, we've got the 2, we've got the 4. Now we need the 8. 6, 5, 1. There's the 8. There's the 6, the 5, and the 1. So the histogram is giving me a visual representation of about how many data points are in each of the sets. Now we're asked to create a stacked box plot and histogram. We're also told to use the exact same scale for our box plot. So above, what I'm going to do is set up our box and with our box plot. And this number right here represents the number 1.5. That's not exactly where our box plot starts. It starts at 1.58. That's the minimum. So if that's 1.5, this would be 1.75. So somewhere in here, and I'm just going to make it right in here. We'll say this is our minimum value of 1.58. So for convenience, I've brought down the 5-number summary here. Our next value should be at 2.48. So I know this line represents 2.5, right? I'm just seeing this from down here. So I'm just coming up, and 2.48 should be just slightly to the left of that. So I'll just draw this is where Q1 is. And then my median value is 2.91. So here's 3. So if this is 3, just slightly to the left of the 3 line, then I need 3.5. So here's 3.5, but a little bit to the right of that, just ever so slightly to the right of that line. And then our final one is 4.29. 4.25 is right in between these, so the 4.29 is a little bit to the right of this line. So what I see here is my box plot, and I'll just finish this off this way. So here are the lines that go out. So so I see them. It's now a stacked box plot. I don't know that I have any commentary on it. The values up here are 1.58. This is, of course, 2.48. This is the 2.91. This is the 3.515. And then finally, this is the 4.29. And again, when you're setting these up, it's not enough to sketch something and just make up where these lines are at. They need to be scaled somewhere. So you can see that the scale that I used is right along the bottom here. These are the numbers that we used, and these numbers then are just translated up to a scale up here, so that this is visually accurate. This looks like a fairly well-centered data set. I think the one thing I can see is there looks like there's a few more values on this side, and that's kind of evident by the fact that this box is a little bit larger, and this whisker pulls out further. So if you look at it, this seems like it's kind of skewed this direction a bit, and there's fewer values over on this side. So not exactly sure what this means, but anyways, this is a stacked box plot and histogram together. And I hope that was the last question. What was the other thing? Describe the center, shape, spread, and outliers. To review the descriptions for shape, see the math notes box in the next lesson. To describe spread, use the interquartile range reviewed in the math notes in the box lesson. So, I guess the interquartile range, that's this distance here. So to calculate the IQR, we're taking 3.515 and we're subtracting 2.48. So that difference is the interquartile range. And I suggest go ahead and read these. We'll be looking at both of these sections in the textbook, but take a look at those and then come up with this answer for C as well.